Okay, last example. So, we see that in the original function, it's 2x squared minus 13x plus 15 over x minus 4. If I were to look at the highest exponents in the numerator and the denominator, I see that the numerator is 1 more than the denominator. So that means that there are no horizontal asymptote, but there's going to be a slant asymptote. So since there's going to be a slant asymptote, I'm going to do that last because it involves long division. So what we're going to do is see if we have any common factors. So here's the factor function. Write that out. Factor function. So I see no common factors, so that means there are no holes. So we don't have to worry about that. Now if we did have one, we have to first identify it and then convert it into a coordinate point, x and y. So no horizontal asymptote, but there's a slant. No holes, so let's focus on vertical asymptote. So we do have a vertical asymptote because we have a factor in the denominator. So vertical asymptote is basically x minus 4 equal to 0, and then we're just going to solve for it. Alright, so x equals 4. So our vertical asymptote is x equals 4. Now, next we usually find the x-intercepts. We have two factors in the x-intercept. Two factors in the numerator, so therefore we're going to have two x-intercepts. So, x-intercept so 2x minus 3 equal to 0, and then x minus 5 equal to 0. Alright, so this one, I want to get rid of 3, so I'm going to add 3 to both sides. 2x equal 3, and then divide by 2. So x equals 3/2. So now for this one, our x-intercept is 3/2, 0. But when it comes to graphing, we need a decimal. So 3/2, that's fairly simple. So it's just basically 1.5, 0. So that's our first x-intercept. Now here's our second one. I want to get rid of 5, so plus 5. So x equals positive 5. So our second intercept is 5, 0. So our first intercept is 1.5, 0, and our second one is 5, 0. So that's our two x-intercept. Now our y-intercept. Alright, pretty simple. Just plug in 0 for all the x's. So 2 times 0 squared, because of the x squared over here, minus 13 times 0 over, plus 15, and then over 0 minus 4. So 0 squared, that would be 0, times 2 will also be 0. Minus 13 times 0 would be minus 0 plus 15 over 0 minus 4 is negative 4. So 0 minus 0 plus 15 on the numerator is just positive 15 over negative 4. So it's a fraction, we have to do long division. So I'm going to write it right here to have some space. So the fraction is negative 15 over 4. So 4 is dividing 15. So I'm going to write in this space right here, 4 divided by 15. Now remember, if it's negative, then what you have at the end is negative. Now 4 can go in 15 3 times. So that's 12. And I'm going to subtract, I'm left with 3. So 4 can't go into 3, so what I'm going to do is I'm going to add a decimal, add a 0, bring it down. That's 30. So 4 does go into 30 7 times, so that's 28. So I'm left with 2. And then let's see what's our second decimal place. So I'm adding a 0, bring it down, that's a 20. So 4 does go into 20 5 times. And if I subtract by 20, the remainder is 0. So negative 15 over 4 will be negative 375. Now I'm going to round up. So it's going to be, I'm going to round up for the first decimal place, one decimal place. So basically negative 3.8 for graphing. But again, negative 15 over 4 is exactly negative 3.75, but I'm going to use this for graphing. So our y-intercept is 0, negative 3.8. So we got our x-intercepts, 2 of them. We got our y-intercepts, and then we got our vertical asymptote. Alright, now we're going to do the slant asymptote. So we have to do long division. So again, here's the work that I did for converting negative 15 over 4 to be negative 3.8. Now we're going to do long division for our slant asymptote. Alright. So x minus 4 will be on the outside, and then 2x squared minus 13x plus 15 and the inside, the dividend. Alright, so I'm going to do this step by step, but you can fast forward if you understand the whole process and check my answer. So focus on the first term. So 2x squared divided by basically 1, x to the 1 power, is just 2x. So I'm going to write 2x here, and then I'm going to multiply 2x to our divisor, which is basically 2x squared minus 8x. So after that, we're going to write 2x squared minus 8x, and then let me zoom in for a bit. We're going to write it here. So 2x squared minus 8x. Now, again, I will put parenthesis and then minus. Now, if you don't want to use parentheses with the minus outside, all you have to do is just change the opposite signs of everything. So, since that's positive, this is going to be negative. Since that's negative, that's going to be plus. So these two will cancel out. Now this negative 13x plus 8x will be negative 5x. And then I'm going to bring down the plus 15. Alright. So we're almost done. Same process as this. We're going to do negative 5x divided by that 1x. So negative 5x divided by 1x. Now these will divide into 1. So then we just only worry about the numbers. So negative 5 divided by 1 is just negative 5. So again, negative 5x divided by 1x is just negative 5. And then I'm going to write negative 5 up here. And then negative 5 times our divisor. So x minus 4, that's our divisor, and then I'm going to multiply. So negative 5x plus 20. So I'm going to put negative 5x here plus 20 with the parentheses and minus. Now, again, if you don't want to use parentheses and you just want to get rid of it, get rid of minus, that's okay. So I'm going to get rid of it. But before I could do anything else, we have to change the opposite signs. So since that's negative, this will become positive. Since that's positive, that becomes negative. So, no parentheses, that's good. Opposite signs, alright. So, these two will cancel out. Positive 15 minus 20, it will be negative 5. So, our remainder is negative 5. 2x minus 5 minus 5 over x minus 4. Now, this would be the answer for long division, but we're only looking for the slant asymptote, so we don't need the remainder. We just need 2x minus 5. So our slant asymptote is y equals 2x minus 5. So here, instead of saying HA, I'm going to say SA for slant asymptote. Y equals 2x minus 5. So that's our slant asymptote. So here's our slant asymptote. And then here's our vertical asymptote. And then don't forget about our first X-intercept. Or second one. And then our y-intercept. Alright, so vertical asymptote, slant asymptote, x-intercept, y-intercept. Alright, now we have a vertical asymptote at 4. So we need 2 points on the left side and 2 points on the right side of it. So if we were to look at the left side, we already have like 1 point, and then we already have 1 point on the right side, then we have another one on the left side, because 1.5 and 0 is less than 4. Now, but here's the thing, we have a slant asymptote that's going to be a bit different. So we have to consider maybe getting more points when it comes to slant asymptote. So again, we have a vertical asymptote and a slant asymptote. So let's take a look. So again, here's the origins, 0, 0. Mark it right here. This is the y-axis. And our x-axis. Now again, we have a vertical asymptote at 4. So 1, 2, 3, 4. So here's 4. Alright, now the slant asymptote. Again, slant asymptote is just like the line that y'all been graphing in Algebra 1, Geometry, and Algebra 2. So here's our slope to x. Now again, slope is just a number, so if we change that to a fraction, it'd be 2 over 1. So right here, 2 over 1, since it's positive, I'm going to go up 2 and then write 1. And then here is our y-intercept, minus 5. So minus 5, -1, -2, -3, -4, -5, right here. So again, our slope is up 2, right 1. Up 2, right 1, up 2, right 1, up 2, right 1, here, here, here. Alright. And then I go the opposite direction for the other side. So here is our slant asymptote. So it's just like how y'all graph a linear line, linear function in Algebra 1, Geometry, and Algebra 2. Alright, now it's not that easy or straightforward when we're picking the x values, because we might have one here, a graph right here, and a graph right here, or a graph right here and right here. So we have to be very careful when we pick our x values. Now, if we take a look at our intercepts, 1.50, so let's take a look at that one. So 1.50, let's see, 1.5 is more than 1, so it's between 1 and 2. So here's our first intercept, and then our second one is 50. So we're going to look at 1, 2, 3, 4, 5. So here's our second x-intercept. Alright, and then let me zoom in a bit for y'all to see. Alright, so these two right here are x-intercept. Now let's do the y-intercept. So 0, -3.8. So zoom in a bit more for y'all. So here is the origin, and then the y-intercept is at 0, -3.8. So -1, -2, -3. So -3.8 is close to -4, so I'm going to mark it right here. So if we take a closer look, we see that we have 2 points right here left of the vertical asymptote. So that means we're actually good with this graph. But if we take a closer look, we only have 1 point on the right side. So that means we just only need 1 more point. So if this is 5, we can do 6. So let's do the value of x equals 6. So all I'm doing is just going to plug in the original function, 2x squared minus 13x plus 15 over x minus 4. So 2 times 6 squared minus 13 times 6, alright, close parenthesis, plus 15 over 6 minus 4. Alright, so 6, that's a square, so 6 squared is 36. So I'm doing step by steps. So 36 right here. Now, minus 13 times 6, and I'm doing mental math, so 8, carry the 1, so that's 78, plus 15 over 6 minus 4 is just 2. So that's pretty good since our denominator is 2. So 2 times 36, that's 72, minus 78 plus 15 over 2. So 72 minus 78, that's negative 6. Negative 6 plus 15 is just 9 over 2. And then if I were to divide 9/2 into a decimal, it would just be 4.5. So our coordinate point is going to be 6, 4.5. So over here, where it's 6, x equals 6, and then zoom in for y'all to see. Alright, again, this is the origin, this is 5, so here's 6, so 1, 2, 3, 4, and then we just need to do 4.5, so midway between 4 and 5, there it is. Let me mark the other points. Alright, so we got 2 points, and if I zoom out for y'all to see, there's nothing here, there's nothing here, so we're good. We got 2 points here, we got 2 points, so that's good. So that's why I said in the rule, most of the time we just need 1 or 2 points left and right of the vertical asymptote. So if I were to graph connecting these right here, again, we have a slant asymptote, so we're just going to graph along the slant asymptote. And if I zoom in for y'all to see, I'm connecting the 2 points right here, and then just going along the vertical asymptote, and then here just along the slant asymptote. Now the other one, I'm going to graph these 2 points together. So the upper right side is going to graph along the slant asymptote, and then the bottom left side of the graph will graph along the vertical asymptote. So here's our graph with a vertical asymptote and a slant asymptote. So again, I only needed 2 points because we got 2 of the x-intercepts, the y-intercepts, so we're good on the left side. Here we just only need 1 more point. So again, you need at least 2 points to connect and graph. And again, just graph along the slant asymptote and the vertical asymptote and you should be fine.